This is example problem 1. It is a tossed up problem. Solve this problem in your notebook to start the worksheet as I solve it right now. So the problem is a pole vaulter. You should read it before I continue here, but the pole vaulter can jump a certain height, a world record of 6.14 meters. And you have to figure out first what speed he has to push himself up from the ground to attain that height, and finally his hang time for his whole time in the air. Right? So let's start off with a illustration of our pole vaulter. Right? There he is with the pole in hand, and he's trying to get over the obstacle. And there's his path right there over it. We could label the height he gets to is his maximum height, it tells us. So I'm going to write D max equals 6.14 meters. Okay. And we could start now to list our givens and try and solve for first what speed, what initial velocity does he leave the ground with. That's going to be initial velocity because it's right when he enters the air. Alright. So we got D, T, A, VI, and VF are always our givens using the kinematic equations. We know that his D max, I'm going to write, is 6.14 meters. We're looking for his initial velocity to leave the ground, right? And while he's in the air, we know he is experiencing gravity's acceleration, which is a negative 9.8 meters per second squared. Why is it a negative? Because gravity always pulls down. Alright, so now that we're mentioning the sign of gravity, we should also mention the sign of the distance. It's a positive. Why is his maximum height a positive? Because it's a distance from the ground. That distance goes up. So that's why it is a positive 6.14 meters. For a dropped object, the distance would be covered down, so it would be a negative. But with something tossed up in the air, it covers distance upward, so it has a positive distance. Alright, so finally, to solve this problem, right now we don't have enough givens to proceed. We have distance and acceleration. We need a third number to plug into our kinematic equations before we can solve for VI, the speed he pushes off the ground with. This is when we should mention that for every tossed up problem you do, I'm going to write it in red, like I wrote it on the board. Every tossed up problem you do, put this star underneath this problem. Tossed up problems use only way up. So every given distance, time, acceleration, initial velocity, final velocity should all represent only the way up, not the whole flight nor the way down. And that's going to be our problem solving method for tossed up problems. That's something you're just going to have to know. You're just going to have to remember. Since we're only using the way up, let's check our givens again. How much distance does he go on the way up? 6.14 meters up to the top. Correct. How much time does it take him to go up? Well, clearly we will be using t up if we use time at all. Acceleration is always gravity's acceleration, even on the way up. Initial velocity is right when the way up starts. Good. And final velocity is when the way up ends. So final velocity is his velocity when he gets right here to the top, because that's where the way up stops. At its maximum height, we know every object tossed up in the air at their maximum height have a velocity of 0. So here, that means the final velocity will be 0. And because we're always using the way up always ends at the top, so the final velocity will always be 0 for a tossed up problem. You could be guaranteed of that. So now you need to choose an equation to solve for his initial velocity. You can look at your kinematic equations. I'll just sketch them right here on the side real quick. Half VI plus VFT, VF squared equals VI squared plus 2AD. Okay. So when we look at the kinematic equations, we should see that the fourth one is the one we want to choose. It's the only one without time in it. So we're going to choose our fourth equation. We'll plug in and solve. VF is 0. VI 2. Negative 9.8. Do not forget the negative. Alright, and your distance is a positive because it's covered upwards. Alright, so let's solve for his initial velocity. We could multiply 2 times negative 9.8 times 6.14. Do that on your calculator. Well, I do it right here. Negative 120.344. Good. I'm going to add that to both sides. And then I have 120.344 equals VI squared. You can square root each side as your last step to get his initial velocity. So do that on your calculator times 120.344 square root. Get about 10.97 meters per second. He leaves the ground with that velocity, right? Remember, always use way up all your variables. So, lastly, we are going to, I'll just put this right here. We're going to solve for his hang time. That's letter B. What is his hang time? So you have the same givens, all right, except look at your list of givens. Hang time is not in there. We're only using the way up again. So we could solve for T up, will be our strategy. Put a question mark next to T up. And we know his initial velocity. We just solved for that, 10.97 meters per second. Get rid of the question mark. And our strategy is solve for T up, and then double T up, and you have your hang time. So we could really use any equation at that point. The simplest one to me always is the second equation. VF equals VI plus AT is our second equation. So we could say 0 equals 10.97. Oh, is 10.97 a positive or negative? Well, our initial velocity is covered upwards when it's a tossed up problem. So that is a positive. All right, always ask that question. Is it a positive or is it a negative when I'm plugging something in? If it's up, it's positive. If it's down, it's negative. Acceleration is negative 9.8. All right, and you're solving for T up in that equation. Right? Always using the way up. Now, you can solve for T up. You could make it, move the 9.8 to the right side. It becomes a positive. You could divide then both sides by 9.8. And you've got T up. 10.97 divided by 9.8 is 1.12 seconds. So your hang time is twice that. 2.24 seconds. That's the hang time. So when we're looking for hang time, never just solve for t, because we're always going to use the way up, so it's going to be t up when you solve for it. And even if you're plugging in a time, you have to plug in t up. But you can't just plug in a hang time into those equations, because we're always using the way up to calculate. Hang time you'll have to find with an extra step always after you use the kinematic equations. Alright, thanks guys.